C10A, question 14. One side of an equilateral triangle of height 24 lies on line I. Given that it's a geometry question, I'm going to draw the picture as we read through it. And for a geometry question, a big chance of getting this question is actually to draw the picture correctly. So this is line L. You have a equilateral triangle. And the height is 24. Okay. We can call it ABC. A circle of radius 12 is tangent to line L and externally tangent to the triangle. So you can have a circle. Its radius is 12. 12 times 2 is 24. So that's convenient because that is telling me the circle is of equal height with the triangle. And try your best to draw the circle. So radius is here. It's going to have one point, another point. Radius is 12. Now, they are asking what is the area of the region external to the triangle and the circle and bounded by the triangle, the circle and line L, which is basically this region. So they want you to figure out, let's call this, if this point is D, E, O, sort of like this DCE, which is not a triangle, but how big is this area? All right. Now let's see, how do we get this question? Firstly, to find this shaded region, what I need is basically the ODCE, the shape, right? So this ODCE minus a portion of the circle, this like arc/secant DE. So the DE is area. Now let's see how to find both of them. So ODCE, we do know OD is 12, OE is 12, and by the way, this angle is 90 degrees, this angle is 90 degrees because they're tangent. Not only that, I actually know, so let's start from ODCE. Actually, no, triangle DCE is equal to 180 degree minus 60 degree equal to 120 degree. Because ACB is equilateral, so that's a 60 degree. Well, now if you take a closer look at this shape, you will see, and I'm actually going to take it out to here. You will see it's actually O, D, E, so 12, 12. And then you have a 90 degree angle, 90 degree angle. This is 120. So actually, apparently you can see if you connect O and C, you're going to divide the angle DCE into two 60 degree angles because they're exactly symmetric. But actually, this is two angles, and so this is actually 2 times, let's just use ODC as an example. This is 12, and this is 30 degree, and 60 degree, and 90 degree. So that's our typical 1, 2, square root of 3. And just be careful, this length 12 is not a hypotenuse. So actually, you will find DC is 4 root 3, and OC is 8 root 3. Because DC is 12 divided by root 3. So the relationship between the two right sides are root 3 and 1. And then you can find LCD's area is 2 times find ODC, the area half times 12 times 4 root 3. So it's 48 root 3. Okay, that looks good. That's sort of your A root B part, right? A root B minus C. Sorry, my slide was missing this A root B minus C pi part. Now you get it. So the A root B part is 48 times root 3. And now you need to figure out the C pi part. What is C pi then? Well, as part of this ODCE investigation, you can find this angle DOE is actually 60 because you have a 19, 90, 120. So what's left has to be 60. And in that sense, this ODE, right, this shape is 1/6 of a whole circle. So that's 1/6 times pi times r squared, 12 squared, which you can find is equal to 24 pi. And the area here is going to be 48 root 3 minus 24 pi, which means your A is 48. And you can see A is 48, B is 3, C is 24. Again, I apologize. My slide was missing this part. So they were saying the area can be expressed as A root B minus C pi. And they're asking you what's A plus B plus C. And you can find that is equal to 75. So answer is D.